In the previous session, we had begun with the structure of diamond. We had talked about some issues, for example, that the atom, each of the carbon atom is joined to the 4 other carbon atoms by covalent bonds, resulting into a tetrahedral shape. We talked about it. Even we talked about that it has a giant atomic stroke molecular structure. Talked about it. We can look at the structure. So now this is the one which it has one form, but after, when they are compacted more and more, we get this is the form. This is the structure, the giant structure, the giant structure of diamond. This is the one. And because of this structure, it has many properties. First, it's the hardest metal, natural substance known, the hardest natural substance known. Why? Because of the strong covalent bonds which are joined together and packed. You see, the atoms are packed together by use of the covalent bonds. These are the covalent bonds. These ones are the covalent bonds. So they are packed together. Because of that, they are strongly attracted. Hence, they are strong. Because still of the strong bonds, covalent bonds between the atoms which are compacted, they have a high melting and boiling point, just because that these covalent bonds will require a lot of energy to be broken. They will require a lot of energy to break those bonds. It's estimated that it's almost about 3,000. That's the temperature required. When we talk about its high density of 3.5 grams per centimeter cubed, it has a high density of about 3.5 grams per centimeter cubed, because of the compactly packed atoms. These atoms are compacted, they are closely packed. It's transparent and does not conduct electricity. Why? Because there is no free electron. Both of them are compacted together because by these strong covalent bonds. There is no free electron. Had there be a free mobile electron, which would have conducted electricity, but it cannot conduct electricity. Why? Because the covalent bonds are strong, holding the atoms. You can look at the properties. We had talked about them. The hardest metal, we talked about it, very high, because of does not conduct electricity, because there is no free electron to carry on. Then let us look at graphite. Graphite, for it has, whereas diamond, for it it's four. Each carbon atom is joined to another one. Each of the carbon atom is joined to 4 other atoms. While for graphite, for it, no, it's not like that. For it, it's joined to covalently to 3. So that's a difference. In diamond, we look at one atom being joined to 4. Then in graphite, we look at one atom being joined to 3, hence forming a hexagonal shape. Here we see a hexagonal shape in graphite, whereas in diamond we look at tetrahedral shape. Why? There are one carbon atom is connected to other 4, while in graphite one carbon atom is connected to other 3. We shall look at the structure. Let us have a look at the structure. You see, each one is connected to 3. This one is connected to this one. They are 3. So these ones are 3. Even these ones are 3. If you look at it, these ones are 3. 3. And they have different layers. There's this one. This is a layer. This one is a layer. That one is a layer. The first layer, and even this one is a layer. These layers are joined by weak forces, or what we call the weak van der Waals forces of attraction are the one which join these two layers. The weak van der Waals forces of attraction are the one which join these two different layers. I told you this is the first layer. This is the first layer. This is the second layer. The second layer. Because of having this weak van der Waals force of attraction, these two different layers can slide over each other. Because of these weak forces of attraction, they can slide over each other. They are slippery and soft, and even contain, for graphite, it contains free mobile electrons which are used to conduct electricity. They have free mobile electrons which are used to conduct electricity, which is not the case with diamond. We talked about diamond is for it, it's compactly packed with strong covalent bonds, whereas here in graphite it's not the case. For it, it's 3 to 1 atom to 3, and it has two different layers. Those two different layers are joined by weak forces of van der Waals, and hence these two layers can slide over each other. They can slide over each other because of this possibility that they can slide over. That's why they are used as lubricants. Because graphite is soft and slippery, the layers can easily slide over each other. That's why we use them as lubricants. And because they contain free electrons, they can conduct electricity. Because they are free electrons, they can conduct electricity. They are opaque, dark in color and shiny. We can talk about the boiling point and the melting point. The boiling point and melting point are relatively high. Why? Because these atoms, the 3 atoms, are connected or joined together by covalent bonds, and covalent bonds require a lot of energy. However, the boiling points of graphite is lower than of diamond, because in graphite we have weak forces of van der Waals which require less energy to break. Altogether, for graphite we shall require less energy compared to diamond, because for diamond it's fully covalent. Here it's partial covalent, partial van der Waals forces of attraction. So the energy required here will be lesser than it were in diamond. Just to go back a little bit to diamond a little bit. Just to go back to diamond a little bit. We can also mention some advantages or some uses of diamond. Diamond is hard. Because it's hard, it's used in driving devices like glass cuts, because of its sparkling appearance. We can use it in jewelry, and it is bright. Because of its sparkling appearance, it's bright. It can be used in laser beams. Then you can come back to graphite. I'd forgot that a little bit. Graphite, first of all, the pencils we use are made up of graphite leads. Why? Because it's soft. Those pencil leads, they're made up of graphite. It's a good conductor, we talked about it, because of the free electrons, therefore it's used as an electrolyte, an electrode. We talked about electrolysis and we saw carbon being used, graphite being used as an electrode. Because of it being soft and slippery, I've talked about that, it's used in lubricants, as a lubricant in most of the vehicles. Some of you have bicycles, you take them and they put for you grease so that you can it can be used to make brushes for electronic motors. How can we know, how can we tell that these two allotropes, carbon, how can we tell that these examples we have given are allotropes of carbon? How can we tell that graphite and diamond is an example of examples of allotropes of carbon? We can tell by getting 1 gram of each of diamond, another gram of graphite, and we burn them in oxygen. We burn them in oxygen. They will form, if we burn them in oxygen, they will form, if we get 1 gram of the other one and 1 gram of this one, they will form 3.67 grams of carbon dioxide gas only. So that shall form only. And that will show that they are allotropes of carbon. That's the way you can do. Just get them, burn them. After burning them in oxygen, they will produce 3.67 grams of carbon, which shows to us that they are allotropes of carbon. We can move on the last one. Which is amorphous carbon. Amorphous carbon, for it, it's black and it has the lowest density. It's not crystal. The other two are crystalline allotropes of carbon. At times we refer to them as the crystalline allotropes of carbon. Then amorphous carbon, for it, it's not crystalline and fairly conducts electricity. Furthermore, this amorphous carbon occurs in many forms, which we shall talk about. For example, the wood charcoal. It occurs in the wood charcoal, the one we use at home. Amanda, that's the wood charcoal. Then it occurs also in animal charcoal. After burning those animal reuses. Then also it occurs in what we call sugar charcoal. This is a very pure form of carbon made by removing elements of water from sugar. E.g., when cane sugar is dehydrated by concentrated sulfuric acid, sugar charcoal is formed. Also, we have what we call lamp black and coal. Coal is also another example of the amorphous carbon. For today, we shall stop there. It was just an introduction. We wanted us to see how we can introduce ours, how we can introduce carbon and its compounds. Next time we shall talk about the reactions of carbon, talk about the lab preparations, and if time allows, we shall even talk about the oxides. For now, have a blessed day. Please try to pass through, and also if there is something missing in your notes, add it. If there is something which you already have, fine. Take some time and read through. Thank you so much for your time. I wish you a blessed weekend, and I hope, God willing, to meet you next week. Thank you so much.